Hello and welcome to the first video for Python for Maya artists. My name is Trevor and I've been writing Python in the game industry for about a decade, mostly inside of Maya. And I'm joined by Perry.
Yeah, I'm also working in the game industry now for about a decade, also using Python on a daily basis, and I'm just here to point out some errors that Trevor's making or add some notations here and there.
And hopefully together we'll get our bases covered and teach you the basics of Maya Python. And what I want to get into is I want to introduce you to Python as an artist because I think it can help you automate steps in your work. And it can help you understand technical artists around you better if you're working with programmers or scripters. And hopefully you'll be able to do two things. One is, you yourself will be able to create simple scripts and automate tasks and save yourself some time. But you also understand better what it takes to make a program. So you might find it easier to ask for feature requests because you realize that it's maybe not that difficult what you're asking. Or you understand a little bit better how to communicate with the programmer if you're trying to explain how to explain what you want from them on a more technical level. So let's get right into it. You can go to Window General Script Editor or click on the bottom right corner here, which is the same icon, and that pops up the Maya Script Editor. You want to make sure that there is a Python tab at the bottom here, so you have to click plus and click on Python to create a new Python tab where you can write some Python code. And then you want to go on the top menu and click on History and make sure that your settings are identical to mine. So you want to show both here. You want to uncheck all of this. And you want to make sure that line numbers and stack trace are checked. And this will basically tell us whenever something is wrong, where it is wrong. And this will tell us how we got there, which is more important in more complicated programs, but we'll get into that later. Right. Oh yeah, I wanted to point out these buttons. So they clear the top half and the bottom half of the screen. Currently there isn't anything there. But if we do some stuff in Maya, it will start printing stuff in here. And by clicking on this button, we will erase that. If you have some code over here and you click on one of these buttons, it will erase that also. So be wary of that. But don't worry, you can click here and press Ctrl Z to undo that change and retrieve your code if you accidentally clicked it anyway. And with that, I'm going to show you our first line of Python, which is going to be print. And that is a function that allows us to display things. And then we need to open bracket and open quote. And I'm going to type hello world. I'm going to close quote and close bracket. And the quotes are automatically detected, and Python makes this yellow, so it shows this is something I recognize as sort of humanly readable text. So if you put it between quotes, what that does is it will turn the piece of text into actual text instead of thinking that it is still Python code. And with these brackets, we group this text together and say this belongs to this print function. So this function will display hello world for us, and we can select our text and press Ctrl Enter to run our code, or we can press this play button. If you forget to select your text, it will delete your code after running it, and you can again click and Ctrl Z to bring it back. As you can see, that actually displays the text hello world like we specified. And to give a little bit of an example of what an error could look like, if you forget to do these quotes, for example, then Python is going to say all this text is just Python code. And when we try to run this as Python code, it will actually get confused and give us an error. And what that tells us is there's an error on line 2. I don't know why it's 2, but it's 3. Sometimes it's off by 1, and sometimes it depends on what you have selected. But it's usually like this line or one below this line or one above this line is where you should start looking for your error. Then it shows the text that is on the line, so it's easy to spot, like, okay, this is the text I'm looking for.
And also sometimes you have that little hat that shows you where the error might occur. And in this case it says hello world. So the end of the world will actually show that that's where Python cannot find what is going on. Maybe you can also turn off the line numbers and stack trace to see what the error would give then, so people have an idea.
Yeah, that's a good idea. So this is what you get without line number and stack trace. So you have no idea where to look for. It's just this error. And it doesn't tell us line 2. It doesn't tell us that this was the text on line 2. It doesn't give that little hat. So you really need this to help you figure out what's going wrong. And the actual error that it says is syntax error, invalid syntax. And what that just means is that Python doesn't think that this is Python code. So you wrote something that it doesn't see as Python code. And that is kind of correct. We wrote something that we should have put between quotes. So usually when you see this, you just go to that line and figure out, like, where did I make a typo? Did I forget a bracket? Did I forget some quotes? And we'll probably encounter this very often by simply making typos. The next step I want to show you is how to create a variable. And a variable is just a name that we give to a value. So I can make this my variable, and then I put an equal sign, and then I put a value, and I can make it 0, for example, and now my variable will refer to the value 0. So if I run this code, it will create my variable inside, like in the background, and I can later on print that same my variable, and this will retrieve the value that was stored under this label. So the variable is just a name that will point to a value, and we can change the value, we can do math with the value, all by using the variable. So we have sort of meaningful words describing what's going on instead of all these numbers and pieces of text that might not be very clear to the reader when you're reading it back a few days later, for example.
Also in this case, if you just select my variable and then execute the code, it will show what's actually in the variable. So you don't always have to print everything. That's
a very useful thing as well. So anything you select and then you press play, what it's gonna do, if it's as long as it's one line or less, it will automatically print it. So I can select this and it will print hello world as well. And I can select my variable and it will print 0 as well, because it's gonna run the code kind of like this. Now I really want to get into Maya, and I'm gonna go to the top. And the first thing you do when you write a script in Maya is you write from Maya import CMDS. And this is the way Python gives us access to Maya's commands, and that is abbreviated as CMDS. Yeah. So next, what you can do is now CMDS is a thing that Python knows about, and it is our gateway to talking to Maya. So you type CMDS dot, and now we can type any function that Maya knows about. So one thing we could do is we could create a Polycube, that's with a capital C, and you put open bracket, close bracket. Brackets essentially mean call this function. So CMDS has the functionality to create a cube, and we have to put brackets there to actually execute that functionality. This is describing like this is a possibility, and this is telling Python to really do that thing. So if I run this line of code, it will have created a cube, and I messed around in the scene earlier so we don't see it. Let me clear the scene, run it again, and here's our cube.
You can also see it at the result in your script editor. It says, we will talk about this later, it's a list of 2 elements. One of them is the cube itself, and the other one is the creator of the cube.
Yeah, that's like the thing where you set the width and the height and the depth in your outliner. It's basically 2 things, and you can have access to both of them. But first I kind of want to get back into Mel a little bit, because what you might see is if I create a cube in the interface, it will also print Polycube and a bunch of other stuff. And whenever you do something in Maya, it will actually write it in the script editor as Mel script, or most of the time. And I think it's very valuable if we understand how to translate this Mel script to Python, because that way we can do something in Maya, translate it, and actually get a macro script that does several actions for us in one go. So I will tell you right away that this can be simplified for now, because what we just did in Python is literally just this in Mel. So what you can see is that we have to prefix it with CMDS and then a dot. and the semicolon goes away, and then we put brackets after the function name to get the same thing. If we want to talk about all these other options, two things to say about that. They can have short names and long names that mean the same. So I prefer to use long names so we actually know what's going on. And I'm going to remove most of these other settings so we can just look at a simpler example. So this is still Mel, and this is just halfway through the translation. I made these names longer so they're more readable for us human beings. And you can kind of guess what's going on. It's creating a cube of 1 by 1 by 1. And in Python, we use the same word. So we could use the short name, which is W, or we could use the long name, which is with. And then instead of that minus, we just type the name, and then we type an equal sign, and then we type the value. And instead of, if we want multiple, we have to put commas in between them instead of spaces. So I can translate this piece of Mel script like this. And we could do the same with all of these arguments. So if I copy paste this, these two are going to be the same thing, and I could keep going, adding this sx, sy, sz, ax, all these things I could just copy over, and that way you can kind of easily translate Mel into Python. So let's clean this up and run this. Well, let's change the size actually, so we can actually get something else, and then run this line of code. And that has created a cube of a different size.
Can you maybe also make the second line and then with the short names so people can see that the short names have the same meaning? And
WHD.
Yes, and then also clean the scene so you only get the 2 cubes.
Ah, right, yeah, good point. So I'm just gonna remove this for now. I'll get back to that in a little bit. But first, when we run this code, we get 2 identical cubes because these names are identical. It's just that in Maya, you have these abbreviations to, you could basically type your scripts faster, but the downside is that when you have to read it a week later, it's going to be less clear. So I prefer to always take my time and write long names. So whenever we read back what we've written, it's going to be very clear. And then a little bit about these pound symbols is how you remove code. So this is called a comment, and you can write anything in there, including code itself. And what it's going to do is it's going to ignore that. So if I clean the scene now and I run all of my code, it's only going to create this one cube because the others are sort of disabled for now. Yeah, I can maybe get into that first. There's a few commands that we will just have to sort of figure out that you don't really get from interacting with the Maya scene. And one of these commands is called ls, which is short for list. And this can do a great number of things, but the main thing we use it for is by adding the argument selection equals true. And then by running this, we can see exactly what we have selected in the Maya scene. So I select this cube and I run my line of code, and it gives us a list with the name of this cube in there. I can select my camera, I can run it again, it gives me the camera name. I can select 2 things and it gives me both of these names, and then they're going to be separated by a comma, so they're separate values. And the way you can find out about this kind of stuff is by going to the documentation. Don't know if this still works. I'm on a bit of an older version of Maya, so it's not always, these links don't always keep working.
If you have problems finding this, you can also just go on Google and search for Maya and then Python and then CMDS. And then any of the arguments that you want to give, like Polycube would be a good one to actually go to this setup.
Yeah, true. You can go Maya, CMDS, Polycube, for example. And it should find the same page.
Yeah. So you go to the command website, and most of the time you get like a single frame. So over on the right you can say show frames, so you get like more information. And if you're in the Mel version, then you can also click on the right top corner to change it to Python.
So yeah, you can switch the syntax and you can see the difference where it's these minus in front of the argument. And here it's the bracket, and then there's the commas in between the arguments. I'm not sure if this button still works.
So this will probably bring you back to the main page.
Yeah, exactly. It used to be a little bit different, but that's fine. I'm going to go back to this one because this is the newer commands. But for example, I can search here as well for ls, and then I can click on that, and you can see that it can do a lot of things. There's tons and tons of options. But the most valuable thing whenever you look for a command is that at the bottom there's always these example scripts. So if you're trying to figure out how ls works, you can find and copy paste these examples and try them out yourself and have a little bit of a play with how they work, because this documentation is very dense, very unclear, or there's it takes some time to make sense. And if you just see the code used in context and you can copy paste it and it just works, that way you can get more of a feeling of how you're actually supposed to use this function.
Also for this example, maybe you can go a little bit more up. You have this import statement in the example itself. So
in the example code.
So in the example code, a lot of people are a little bit baffled by this because you import maya.cmds as CMDS, and we import from Maya the CMDS command. Right,
yeah. This is shorter, and I think it's the standard way to go. The S keyword is just to rename CMDS to something else, which we have no reason to do. And renaming it to the same name is even more weird, so I never really understood why they did it like that.
It's something that they added into Python because most libraries that you use will have like utils or anything that resembles that. And if you have like multiple libraries that use utils, you might want to rename them so you don't have a clash in there.
Yeah, it's especially if you have not only Maya but some other package that gives you CMDS, then you run into issues, and then you can use as to rename it to something else. So one of them is called something different, so you don't have these two clashing names. And what I mean by clashing names is we could go back to this myVariable example. If I make a different myVariable, of course it's going to overwrite the previous myVariable. If I run this code, it's going to make a variable 0 and print it, and then it's going to make a variable 2 and print that. And obviously we lost the 0, it's gone now. We overrode it with the 2.
It doesn't even need to be like an integer, it can even be a string. So the entire type will also be different.
Yeah, you could say this is hello world and this is 2, and we could print it like that. And then it will first print hello world, and then it will print 2, and we just overwrite whatever is in there with something else. Some other, I think, basic stuff that we should know about is how to do math. So Python is actually a great calculator if you're ever looking to calculate something, because you can, besides these variables, let's first do an example where we just write some numbers, right? 2 plus 2 times 4. That just works. But because myVariable equals 2, we could also just say I'm going to print myVariable plus myVariable times 4. And that still works, because this, anytime you write a number, you can put it in a variable. And you can replace that number with the variable, but not just the number. You can pretty much any piece of code you could turn into a variable. So I can do some maths and just say result equals this piece of maths, and then I'm going to print the result instead of doing it all in one go. And this way, where we can create, instead of one really long and complicated line of Python, we can break it up over multiple lines and into multiple steps. And that also helps readability and overview. And there's, I think, all the basic math is in there. You can do divide by 2, run that. It will just print 5, because 10 divided by 2 is 5. You can, oh yeah, another really cool thing is you can, let's say you want to update the result with half of the result. You can do result equals result divided by 2. So here the result is 10, and then it's going to divide by 2, and that's 5, and then it's going to put that back into the result. If I copy paste this print, we can kind of see what's happening. We compute a 10, and then we overwrite the result with result divided by 2. But there's a shorter version of this, which is result divided equals 2. So instead of having to write it like this, you can just put that equal sign over there, and then it's going to do the exact same thing.
But now it will give an error because you have a semicolon.
Oh, haha. I failed to type. It's actually kind of good to look at this error. Am I still set up correctly? Yeah. Name resu is not defined, so it sees a variable name called resu, and then it sees a semicolon, and then it says, this is probably the end of your code because something different is going on. And then it tells us there is no variable named resu. So yeah, this name error means there is no variable with this name, and it also very often means you made a typo.
Okay.
Oh, I'm doing it again.
Another one that is cool to note out is you have star is multiply and double star is the power of.
Right, yeah. It's not something I use very often, but you can, if you have to do like 2 times 2 times 2 times 2, that is the same as 2 to the power of 4. And in Python, you can do double star, just to say we're going to do 2 times 2, but 4 times, or 6 times, and then it's the same as this.
And if you do to the power of the half, then you actually have the square root.
Right. But that's a little bit math heavy, I think, so yes. I'm not going to go in there yet. Yeah, I think we can take this into Maya because I want to show how you could, for example, start moving this cube around from script. So we've got our, I'm going to continue at the bottom. Let's take our cube along, copy paste that here.
Let's make sure that the video is not in the way.
Oh yeah, that's a good thing to check. We are a little bit on the edge, right. So I'm going to create a cube, and I want to get the created cube. I can also put into a variable, so I'm going to call this my cube equals. And by running this code, I can now print my cube, and that will give me the cube and this thing, which is just the settings of the cube, where we find the width, height, and depth that we put in. And then we want to actually start accessing the translate, for example. So the first thing we need to do is we get the first of these two names, because we cannot get a translate of this list of things. We can only get the translate of pcube2 because that has a translate attribute. The way to do that is by putting square brackets and a number. The 0 is the 0th or the first element in the list, and 1 is the second. So in code, it's always kind of off by 1.
So computers always count from 0.
So yeah, that is something to try and get in your head, because you will put a 1 there when you want the first item, and that is not what you're supposed to do. Now if I print my cube again, I just have the pcube2. Whenever you're in doubt of why something doesn't work, I recommend always printing. You can see I'm using it a lot. That's not just for demonstration. When you're writing code, you should print very often. You just check, what am I getting? What's in my variable? What's going on? Then the next function that I want to introduce you to is called getAttr. And these are things you can kind of look up in the Maya documentation as well, of course, the command reference that I just showed you. But I want to go over a few of the more important commands that you'll use very often, and hopefully you can avoid having to read for hours in this trying to find what you're looking for, because they can have kind of weird names as well.
Also, one thing to note is that we actually put the polycube that is created into a variable. This normally you see people that use the name of the cube that is created, but because we create a polycube and that name is already existing, Maya adds a different number at the end, and we want to make sure that the cube that we're working with is the one that's created just now.
Right, yeah, that's a good point. Normally when I create a polycube, it will be called pcube1. So instead of this variable where I get the 0 out of the list, etc., I could just say my cube equals p cube 1, and I can expect that to work. But when we have this naming conflict, and I can create more cubes to prove it, it keeps changing the name, and then my code is gonna handle the wrong cube if I just write the name that I think it would be. So by using this value that we get and giving it a variable name, and then getting the first item in that list of 2 cube shapes, I can actually have access to the right cube that I indeed just created. I'm always guaranteed to get the cube that I want, that I have ownership over. And with that said, we can get the attribute, and the attribute is, it's kind of similar to Python, I guess, because you can get the pcube1.translateX attribute, and it's a little bit analogous to the CMDS.function name. You know, it's also, you get something from the Maya commands module. Here you get something from this cube object. So this is the simple way to do it, but because we have this variable name that is that should be outside of these quotes, because this is code, this is a variable name, and this is text. This is something we just want to write down verbatim. And the way to make this work is you have to put a plus. So it's going to say this piece of text in this variable and this piece of text between these quotes should be joined together as one piece of text. I can select that and print that. And you can see it's the exact same thing, but it got from the variable and it made the right attribute name of the cube that I just created. And then I can get that attribute, and then that will be 0.
Also, if you're unsure what the name of your variable is, just try to adjust it in the channel box or in the attribute editor, and then you will get a printout from Maya itself.
Yeah, so this is, you can see how you can set attributes in Mel. It's the setAttr command, and then you can see this is translate X and this is translate Y. And what's important to note is that the channel box sort of prettifies this stuff. It puts spaces, it puts capital letters, but in code they are not there. They have to be lowercase and all together. So this is actually a good thing to do. I'm going to get this translate X, and I'm going to do cmds.setAttr. So I'm translating this piece of Mel code now. I'm putting CMDS dot in front of it. I'm using the same function name, but I'm putting the brackets, and then all the other stuff goes between the brackets. And I know that this is, you know, it's this. I want to keep using my variable. I'm going to copy paste that, and I'm going to set the value to, for example, 1.0. I can run that, and it will change the translate X to 1. But I can also use the translate X that I just got. So well, now it's not going to do anything because it's going to get and set the same value. But what if I wanted to multiply it by 2? That keeps adding up. You see 16, 32, 64. So now we're really getting data from the scene and manipulating it and putting it back. And that is what kind of programming is starting to happen. So the next thing I think is nice to look at is getting the selection. I already showed you the ls thing a little bit earlier. So I'm going to bring that back, cmds.ls selection equals true, and selected objects equals. So now I'm going to get the selection from Maya, whatever I have currently selected, and store it as a variable. And this too will be a list of objects. So I could select multiple objects, and it will give me a list of 2 objects. Sorry, I messed up the selection. And what we can do for now is say my cube is going to be the first selected object equals selected objects, and then again we get 0, not 1, we get 0. That way, I have to run all of this. That way my cube will represent the first object that I selected in the scene, and we're just not going to think about the rest for now. Just going to assume that we're aiming for 1 object exactly.
Also, let's talk a little bit about the error that you just got, because you assumed that you run the selected object line beforehand and you only selected the command.
Right, this one.
Yeah.
Yeah, so whenever you run this code that I'm running here, it's going to be stored. Maya is going to remember what I did. So what I just did was I selected this and pressed play, but I never selected the whole line of code. So it only got the selection and printed it. It never created the variable and saved it into the variable. So by selecting the whole line, you don't see it print, but it's just going to put it in the variable. And now this variable exists, and if you forget to do that, you get this name error again, because it says this is not defined, and even though you can see it in the code, you have to make sure that you actually run the code, because else it's not going to exist yet. So what you type hasn't happened yet until you actually select it and play it. So I thought what could be fun is if we create a selected object or create a script that takes the selected object and snaps it on the floor if it is below the floor. So I've got Y up right now, so I'm going to get the translate Y attribute of my selected cube. And first I'm going to print that, make sure that all of this works in one go. No, I should have written plus. And that indeed gives me this value over here. And then I want to write an if check. And an if check is basically, we're gonna make sure something is true before we run a piece of code. So in this case, we can say if space, and then I'm gonna write my condition. So that's gonna be translate Y is less than, and this is the less than symbol, less than 0, that means it's under the floor. And then I put a colon, and that means like, then we will do the code that follows. Something you might notice is that when I press enter, Maya actually puts some spaces in front of it, and that's what this is all about. So I can print this, and any code that is indented like this and it has these spaces in front of it will be run only if translate Y is less than 0. So I can print some more stuff. I can have multiple lines, but as soon as I stop, always print it, we're back to normal code. So I can select all of this, and I can run this, and it's gonna print the fact that the cube is under the floor twice, because I have it twice. And then it's gonna print always printed as well, because it's outside of the if check. But now if I move the cube above the floor, and I run the same bit of code, it only prints always printed, because that is outside of the if check.
Might be also good to talk about indentation errors in this case, because some programs use 4 spaces and some programs use tabs. That might be a problem that you
this is if you copy paste code, especially between different programs, different text editors, sometimes you do not get 4 spaces like this, but you get a tab character. I don't think I can even write a tab character here. If I put tab, Maya actually writes 4 spaces, but in some other programs it writes a tab. And the problem with Python is basically that the tab looks like 4 spaces, but it is one space basically. So when we run the code, Python will give us an indentation error, and it's going to be the same as if I do this. So to give you an example, this is 4 spaces. So we have an if check, then we have indented code, which is related to the if check, and then we go back, but then it's 1 space, and we came from 0 space. So Python says, I don't know where this code belongs, and that's called an indentation error. So you need to make sure that if you see this, you need to make sure that you don't have any tabs going on, or you need to search replace. So I think you can go like edit, search and replace. And then you can, so in Maya I can write a tab, but if you go to a different text editor, write a tab. I'm doing that off screen right now. You can copy and paste a tab in here, and now this is a tab. So if I try to select it, you see it's 1 character that's very big. And I can replace that with 1, 2, 3, 4 spaces, and then replace all. And that would fix your code if it came from a text editor that's using tabs. And that's also how I check for these things. So I go to this white space and I drag my cursor to see, am I selecting one by one these spaces, or am I selecting, one big block, which is then the tab character. a little bit back to this if check. So we wrote an if, and then a statement, and then a colon. And there's a few things that we can check for, right? So it's under the floor. We could put if it is equal to 0, and that's with double equals. The single equals sets a value, double equals checks a value, and that's why it's double, because we are already using the single equals for something else. Then it is on the floor, and we could do this again for greater than, and that's the other symbol. Greater than symbol is just above the floor. I think it's good to know that these all exist, and there's a few more where it's you can combine them. So you have greater equals, and you have less equals, and you have not equals. But you also have a not word in Python, so you could always, if you have an if check, you're like, oh no, I meant the opposite thing of exactly what's going on. Whoa, I pressed the button. You can put a not in front of it, and if you want to be extra sure, you can put some brackets. So you say this thing, but the opposite of that. So you could kind of negate what's going on as well. I think these are actually interchangeable, the exclamation point and the not. So let's say this is not equals to, then it is print not on the floor. So I have this equals check, I just copy pasted it, put brackets around it, put a not in front of it, and I get the opposite case. So now when I run this code, it will print above the floor and not on the floor, and then always print it. And if I manually put 0 in the channel box, so it's exactly on the floor, it will just put on the floor. So only this one is going to trigger, and all these other ones, it's not less than 0, it's not bigger than 0, and it is equal to 0, but it's not equal to 0. I love these double negatives. Right, so to put this all together a little bit, what I actually want to do is, if it is less than 0, I want to set the attribute to 0, and if it is greater than 0 or equal to 0, I just want to leave it alone. So I'm just gonna copy paste this a little bit. We have a clean slate. I'm just gonna get the selection. We're gonna get the first object in our selection. We're gonna get its translate y. And then we're gonna say if translate y is less than 0. We're gonna say translate y is equal to 0. So we're gonna change the value only if it's under the floor. We're gonna put it on the floor. And then we're gonna do CMDS.setAttr. We're gonna put my cube plus dot translate y, and then we're going to put translate y, and then I can run all of this code. Nothing happens on the floor, nothing happens above the floor, something happens because we're below the floor. You can keep moving it down and it will snap back. And this is where you really start going beyond simple macros. So if you record what you do in the scene and you try and translate your mel to Python, you automate a task. But once you get if checks involved, you can actually make your tasks smarter. And it's more than just automating a few button presses or hotkeys. It's really gonna make decisions based on some rules that you set down. And that's where the real power comes in from programming with Python. Yeah, I think that's all I wanted to show in the first session, because it's getting a little bit lengthy. So I hope this was a good introduction into the basics of running Python commands in mel and running if checks with them and trying to find stuff in the command reference. And with that, thank you for watching.
Thank you for watching.